Have you ever wondered how roller coasters work? These towering structures of steel and wood are more than just amusement park attractions. They are marvels of engineering and physics. From the moment you strap into your seat and hear the click of the safety harness, you're in for an experience that combines speed, height, and gravity in a way that few other activities can match. What makes them so thrilling? It's not magic, it's a carefully orchestrated dance of forces and energies. The thrill you feel as you plummet down a steep drop or loop through a corkscrew is the result of precise calculations and meticulous design. It's all thanks to physics. The journey begins with the climb up the lift hill, where the coaster car is slowly pulled to the highest point of the track. This is where potential energy is stored like a coiled spring ready to release its energy. Join me as we explore the science behind these scream machines. We'll delve into the principles of gravity, inertia, and centripetal force, and see how they work together to create the sensations of speed and weightlessness. We'll uncover how gravity, energy, and clever engineering combine to create an unforgettable ride. As the coaster car races down the first drop, potential energy is converted into kinetic energy, propelling you forward at exhilarating speeds. Get ready for a wild ride through the world of physics. We'll explore how the shape of the track and the design of the coaster car influence the ride experience, from the smooth curves of a loop to the sharp twists of a corkscrew. We'll see how roller coasters turn potential energy into heart-pumping kinetic energy. As you reach the peak of a climb, the anticipation builds, and then, in an instant, you're hurtling downwards, feeling the rush of wind and the pull of gravity. We'll explore the forces that pin you to your seat, and the ones that make you feel like you're floating. G-forces, or gravitational forces, play a crucial role in the roller coaster experience, creating sensations of heaviness and lightness as you navigate the twists and turns. And we'll discover how engineers design these rides to be both exhilarating and safe. From the materials used in construction to the rigorous safety checks, every aspect is carefully planned to ensure that you can enjoy the thrill without any risk. So buckle up and let's dive in. Whether you're a thrill seeker or just curious about the science behind the fun, this journey will give you a new appreciation for the art and engineering of roller coasters. Get ready to experience the ultimate blend of excitement and education as we uncover the secrets of these incredible machines. Imagine yourself strapped into a roller coaster, slowly chugging up that first massive hill. The higher you climb, the more anticipation builds. What you're experiencing is the buildup of. Think of it like this. When you lift something heavy, you use energy. That energy doesn't just disappear, it's stored in the object as potential energy. The higher you lift it, the more potential energy it has. It's the same with roller coasters. As the coaster climbs the lift hill, it's gaining potential energy. This stored energy is like a battery, ready to be unleashed, and unleash it we shall. Here comes the fun part, the first drop. As the coaster plunges down that initial slope, all that stored potential energy transforms into the energy of motion. The higher the drop, the more potential energy is converted, and the faster the coaster goes. Remember that feeling in your stomach when the coaster first plummets? That's the rush of acceleration as potential energy rapidly changes into kinetic energy. It's a thrilling example of physics in action. The shape and angle of each drop are carefully calculated to create different sensations. A steep drop converts more potential energy into kinetic energy, resulting in a faster, more intense experience. A more gradual drop creates a slower, more leisurely feeling. Roller coaster designers play with these drops, creating a symphony of thrills throughout the ride. Each rise, fall, and curve is all about manipulating energy and forces to keep you on the edge of your seat. Section 5. The brakes are on friction and air resistance. Now, you might be thinking, if the first drop is the highest, shouldn't the coaster keep going faster and faster? It seems logical, right? The higher the drop, the more potential energy is converted into kinetic energy, making the coaster speed up as it descends. Well, not quite. There are party poopers at play here like friction and air resistance. These forces are constantly working against the motion of the roller coaster, ensuring it doesn't reach dangerously high speeds. Friction is the force that resists motion when two surfaces rub together, like the coaster wheels on the track. Every time the wheels spin, they encounter resistance from the track, which generates heat and slows the coaster down. This friction is crucial for safety, as it helps control the speed of the ride. Air resistance is the force air exerts on a moving object. As the coaster speeds through the air, it has to push air molecules out of the way, creating drag. This drag increases with speed, meaning the faster the coaster goes, the more air resistance it encounters. These forces act like brakes, gradually slowing the coaster down. Without them, the coaster would continue to accelerate, potentially reaching unsafe speeds. Engineers design roller coasters with these forces in mind, ensuring a thrilling yet safe experience for riders. That's why those later hills and drops aren't as tall as the first one. The coaster has less energy to work with. As the ride progresses, friction and air resistance continuously sap energy from the coaster, making each subsequent hill a bit lower. This careful balance ensures that the ride remains exciting without compromising safety. Engineers spend countless hours calculating and simulating these forces to design the perfect ride. They use advanced computer models to predict how friction and air resistance will affect the coaster's speed and energy throughout the ride. This meticulous planning ensures that every twist, turn and drop is both exhilarating and safe. Regular maintenance is also crucial in managing friction and air resistance. Maintenance crews frequently inspect and service the coaster's wheels, tracks and brake systems to ensure everything is in optimal condition. This ongoing care helps maintain the balance of forces, keeping the ride smooth and safe for everyone. So, the next time you're on a roller coaster, remember the invisible forces at play. Friction and air resistance might be the unsung heroes of your thrilling ride, working behind the scenes to keep you safe while you scream your lungs out. Enjoy the ride, knowing that every twist and turn has been carefully crafted with these forces in mind. Section 6. Defying gravity loops and inertial forces. Now let's talk about those gravity-defying loops. How do you stay in your seat when you're upside down? Thank for that. Inertia is an object's tendency to keep doing what it's doing, whether it's moving or staying still. When you're going around a loop, your body wants to keep moving in a straight line, but the track forces you to move in a circle. This creates a feeling of being pushed outward even when you're upside down. Don't worry though, the coaster is designed to keep you safely in your seat. Section 7. The smooth scream, clothoid, loops, and comfort. Have you ever wondered why most roller coaster loops aren't perfectly circular? They're often shaped more like a teardrop, wider at the bottom and narrower at the top. These are called, and they're designed for your comfort. A circular loop would create too much force at the bottom, making you feel squished. Clothoid loops spread out the force more evenly, giving you a smoother, more enjoyable ride. It's all about finding that sweet spot between thrill and comfort. Section 8. Feeling the force, G-forces and airtime. One of the most exhilarating parts of a roller coaster ride is the feeling of weightlessness, known as airtime. This sensation is a favorite among thrill seekers and roller coaster enthusiasts alike. But what exactly causes this thrilling experience? This occurs when the forces acting on your body change rapidly, like when you go over a hill or through a dip. As the roller coaster climbs a hill, gravity pulls you down while the coaster pulls you up, creating a momentary feeling of weightlessness. Conversely, as the coaster dips into a valley, the forces combine to push you into your seat, making you feel heavier. These forces are measured in G-forces, which are a measure of acceleration felt as weight. 1G is the force of gravity we feel every day. It's the standard force that keeps us grounded on Earth. When you're just walking around or standing still, you're experiencing 1G. On a roller coaster, you might experience moments of 3 or 4 Gs, making you feel several times heavier than usual. This happens during sharp turns, rapid descents, or sudden accelerations. The higher the G-force, the more intense the sensation. Then, as you crest a hill, you might experience less than 1G, giving you that feeling of floating out of your seat. This is the airtime that coaster fans crave. It's a brief moment where the forces balance out, and you feel almost weightless. It's all part of the ride. The interplay of G-forces and airtime is what makes roller coasters so thrilling. Each twist, turn and drop is carefully designed to maximize these sensations, providing an unforgettable experience. So next time you're on a roller coaster, pay attention to these forces at play. Feel the weightlessness as you soar over hills and the intense pressure as you dive into valleys. It's a dance of physics and engineering, all crafted to give you the ride of your life. Roller coaster designers use complex calculations and simulations to predict the G-forces and airtime that riders will experience. They tweak the angles, speeds and heights to ensure that each ride is both safe and exhilarating. It's a blend of art and science where every detail matters. Testing is a crucial part of the process. Before a roller coaster opens to the public, It undergoes rigorous testing to measure the G-forces and ensure that the ride delivers the intended experience. Sensors and dummies are used to simulate real riders, and adjustments are made as needed. The result is a finely tuned machine that provides thrills and excitement to millions of people around the world. So the next time you buckle up for a roller coaster ride, remember the science and engineering that went into creating those moments of pure exhilaration. Enjoy the G-forces and airtime and let yourself be carried away by the magic of the ride. Section 9. Conclusion: Engineering Exhilaration. So there you have it, the physics behind the thrills. Roller coasters are a testament to the power of science and engineering. From the initial climb to those exhilarating drops and loops, it's all carefully calculated to deliver a safe and unforgettable experience. Next time you're strapping yourself into one of these scream machines, take a moment to appreciate the forces at play. It's a wild ride through the laws of physics, and it's all thanks to the magic of science and engineering.